Hi everyone and welcome to my presentation on fortifying progressive delivery with automated quality gates based on SRE principles and best practices. Welcome to DevOps Stage. My name is Jürgen Etzlstorfer and I work for a company called Dynatrace in Austria. So here we go. I'm here a technology strategist at Dynatrace and a DevOps activist, but I'm also the community lead of an open source project called Captain, and I will be using Captain as one example here, how to fortify your continuous delivery pipelines by using quality gates of Captain that already include SRE best practices and SRE principles. If you want to connect with me, feel free to follow me on Twitter or connect with me on LinkedIn. Let's just jump right in. So let's take a look at a common CICD pipeline. It's a little bit simplified, but it should just give us an example what we actually want to do and how most of those pipelines look like. I know they are more complicated, but like from a more, let's say, conceptual perspective, they start with building the artifacts. There might be some unit testing already. Then we want to deploy it to some test environment. So we start to deploy it, maybe just as a container or whatever is like your building artifact. You're starting to run some tests in your testing environment, and then you want to decide if the quality is good enough, if you can promote it to the next stage, either pre-production or already production, or if the quality is not good enough and you have to give it back to the developers to do another iteration and increase the quality of the service. So it basically starts with finding out what is the quality of the service. So we might run some functional testing, but the problem is tests sometimes are not long enough, so it's very difficult to find if there is already a trend going into a direction where it's not very beneficial for this application. We also need to compare different performance metrics. So we are running a performance test for a couple of minutes or hours. So afterwards, we need to find out what is actually the performance compared to the previous run or to the previous runs. Is there any regression? Is there any difference that I have to take care of in my decision process? And we have to define which data we base all our decisions on. So we basically have to make sure that we only query the data that is affected by this test. Otherwise, we have a lot of noise in it. So there's a lot of decision process going on. And so there's a lot of things going on how to actually query everything. And we have seen like big spreadsheets with a lot of data in it that will be gathered from different sources, typed in, and then you have some kind of calculation and you define if this build is good or not, if you are already able to release it or just put it to pre-prod to do some other testing. But all in all, this testing takes quite a lot of time, or not only the testing, but actually the approval process takes quite a lot of time. And we've seen it might take up to 30 to 60 minutes just to do this evaluation. And you can imagine if you want to do like blue-green deployments, you want to do multiple deployments per day, you want to even go maybe for canary releases where you do a lot of, you do have your release process by always putting more and more traffic onto a new version. Doing a 60-minute evaluation after each iteration when you increase some percentage on your canary release is not very feasible. So that's very, very time consuming, and we need some better approaches here. And I want to introduce the concept of a quality gate, which is not a new concept, but I just have to kind of clarify what I mean with the quality gate in terms of this presentation. So a quality gate is really some decision process that is automated based on some score. So the first part of the quality gate is really to gather the metrics. Once you have the metrics, like the response time, the error rate, memory consumption, whatever metrics you need to generate a score. And the score, you generate this upon some quality criteria that you define for your application and for microservice, which might be like the memory consumption, CPU usage, response time, and you define some criteria upon it so you can generate a score. And then the total score will basically on the total score, you will make your decision on. So you will have a decision-making process, and if this process results in a thumbs up, you can promote it to the next stage. If this process results in a thumbs down, you have to hold it back to not promote it to the next stage, or even roll it back to the previous version. And then there comes the new build, and actually you want to do this whole process again and again. So it's really a continuous evaluation. Maybe you even want to start this process sometimes in production just to check the quality of the services, just to gather the matches, generate the score, make a decision. Do I have to roll it back to a previous build, or everything is fine? So that's really the concept of a quality gate that you want to automate. You want to automate the gathering of the metrics, the generation of the score, the decision-making process. Everything should be automated so you can do it as often as possible to really guarantee the specified quality of your service. So how can it look like in our approval process that we have seen before? So on the top, we see the previous slides, and on the bottom, we see how it can really work with Jenkins, Captain, and some metrics from Prometheus. So basically, when we start to run the tests, we are already labeling these tests. We know that we're now starting the tests, so that in the next phase, when we trigger the quality gates with defined quality criteria, and we see here some cryptic quality criteria, which will make more sense later in this presentation. But when we see here this quality criteria, like the response time for the 95th percentile, or the CPU separation, or some Java garbage collector metrics, this can be used to pull all these metrics that are defined with the label. So we actually make sure to get the right data for the actual quality evaluation. And then we can generate the score. We validate our service level objectives. That's already one of those SRE terms, service level objectives, in short SLOs, where we can basically define a quality criteria. We define a goal and objective upon service level indicators, which are our metrics. So with this, we can do an automated quality evaluation. We can define a score. And if the score, let's say, is 85%, we can define it's a successful evaluation, and we can promote it to the next stage. If it's not successful, if the score is like 50%, we can roll it back, hold it back, inform our developers, open a Slack channel, open up a ticket, whatever. But we have an automated mechanism how to evaluate this. And with this automated mechanism, we can really reduce the time significantly. So let me show how these SRE principles basically come into this game. So we are differentiating between three different SRE principles or best practices. The first one are SLIs. SLI is short for service level indicator. And we can really think of the service level indicator as a measurable metric. It's really like a metric like the error rate of login requests. We are reusing, or we are actually using the service level indicator in service level objectives. An objective is really a goal based upon service level indicator. So for example, the error rate of our login requests, which is our service level indicator, must be less than 2%. We can even say the error rate of our login requests must be less than 2% within the last 10 minutes. So we have some objective that we can evaluate. And then upon the service level objectives, we can even define service level agreements, which are more business related agreements between the consumer and the provider. And these are also typically based on SLOs. There is a very interesting YouTube video. It's about like 10 minutes, but it's I've linked it here. It's from Google, and they will talk a little bit more about SLIs, SLOs, and SLAs. And at the very end of this of the video, there's also a short summary. So make sure also to check this out to get a very clear understanding of what an SLI, an SLO, and an SLA is. So now we have defined the concepts of SLIs, SLOs. We have already seen a very short example how to use it in our delivery pipeline. But I want to introduce an open source project that is making active use and heavy use of those SRE principles. And I want to show you how you can use it also in your own pipelines. So the project I'm talking about is called Captain, and it's an event-based control plane for continuous delivery and automated operation. So it's usually installed in a Kubernetes cluster, but you can also run it on a small VM. And it's a control plane where you send events to or receive events. So it's easily integrated with other tools because the only thing you have to do is send events to the Captain control plane and then receive events from the Captain control plane. It's not such a thing like a Kubernetes operator that lives in the cluster and like as an operator, but it's really an event-based mechanism how to get things done. And one part, it's also sketched here, is this validation service. We call it also the Captain Quality Gate. And for this, you can just trigger the evaluation. Captain will do all the rest for you, the whole fetching of the metrics, evaluating of the SLOs, and sending back the result. Everything is done by Captain, so you can use it for your quality gates. So how does it look like to define an SLI and an SLO file, and then how to use the Captain quality gates? So if you remember in the previous slides, I had the quality gate was one part of the whole CD pipeline. So after you trigger the tests, or after actually the tests have finished, you want to do your evaluation. So first for the evaluation, we need some data. And the data is defined in the service level indicator file. So we define indicators, they have a name, and they also have a value, and the value is basically the PromQL, how to fetch the data for this one service level indicator. So one example is how to fetch the error rate or the number of database calls or the response time. Captain already has a built-in set of those indicators. So it already is, let's call it a built-in library, but you can easily extend it by just defining your own service level indicator file. So with this, we, for example, map the response time in the 90th percentile with this query to define a histogram with the quantile, and we take the .90 quantile, and then we do some sum and some rates, and we basically define a longer PromQL, and this will give us back the response time. And we can reuse this in our service level objective file. So the objectives really take the indicators and we define some objectives upon it, some goals upon it. So for example, the error rate is only allowed to be less or equal to 1 to get full points for this evaluation. Full points, I say, because it's a pass criteria. In Captain, we define pass and warning. If you're inside pass, you get full points. If you get inside warning, you get 0.5 points. So for example, for the number of database calls, we also have this in the example here on the left-hand side. If the number of database calls stays within an increase of +2% to the previous runs, everything's good, and we are receiving full points for this evaluation. If we're not within this 2%, maybe we have 4%, then Captain will go ahead and check also the warning criteria. But so if we are increasing by like 4%, but we're still staying below the fixed threshold of 10 database calls per transaction or per test run, then it's still good. We are getting 0.5 points for this evaluation. But if we're exceeding more than 2%, and if we're using more than 10 database calls for this test run, then we won't get any points for this SLI. We might still get points for the other SLIs. We can also define SLIs as a key SLI that has to be passing. We can define multiple criteria. We can mix and match. Basically, we can combine them. And we can define the total score. And this total score is basically giving up the decision if it's a thumbs up or a thumbs down for the whole evaluation. So how can we use it? There are basically two ways. I want to show you. The first one is to use the Captain CLI. So you connect the Captain CLI to the Captain installation of the cluster, and you start the evaluation for a given time frame for a given service. It can be a microservice. It can also be a monolithic application. It's just that Captain knows where to look for the SLI and the SLO file in its internal Git repository. That's where you put those files. So it's actually not that you have to define the files each time you do the evaluation, as I sketched here, but just that you know we need the SLI and the SLO file. Captain will find it actually in its internal Git repository. So Captain receives this event. The CLI basically just sends a cloud event to the Captain control plane. The Captain control plane will send it to the Captain quality gate, and the Captain quality gate will reach out to all those SLI providers, we call it, so we can easily connect to different data sources, like I've written here, to Prometheus, to Neolo, to other tools. So it will reach out to all these different SLIs and will query all the data that is needed to evaluate the SLO file. So it will reach out for the error rate, the JVM memory, the number of database calls in this case. It will fetch all this data and it will evaluate the data. It will generate the score. So by generating the score, it will also come up with a total score at the end. And if total score is like 9 out of 10, that's higher or equal to our pass total score criteria, we will basically get a thumbs up and at the total pass of the quality gate. If it's a little bit lower or even below the warning threshold, then it's a failing of the quality gate. If you are using Captain quality gates, you get like the full evaluation as a cloud event. You receive it and you can interpret and you can do whatever you want with this result. If you're using Captain also as a deployment tool in its full flavor, I would say, then Captain already decides what to do. So if it's a pass, Captain will already promote it to the next stage. So it's not only a tool for doing quality gates, it's a tool for controlling the whole CD workflow. But if you already have Jenkins, for example, then you might want to include Captain quality gates only, or you want to switch to Captain to do the whole CD part for you. You still want to do CI in Jenkins. That's not part of Captain anyway. So how to define SLIs and SLOs. We've seen how they look like. And for defining SLIs, Captain has a built-in library of some SLIs already. They are based on the red metrics. So you always get some metrics out of the box, like the response time, the error rate, and the throughput. These are part of the red metrics. They might be named a little bit different, but basically these three metrics are always part of the red metrics. Also, the Prometheus service that is gathering all the data, it's open sourced. So if you want to take a look at all the metrics that is already provided for Prometheus, I've also put the link here. We also have other data connectors that you will find also in the Captain contribution repository. You also might want to extend the library. So you can extend either the library by contributing back to Captain, or you can just extend it by defining it in your own SLI service. So in the previous slide, we've seen the SLI file, and you can just add more and more lines to it by, for example, defining let's say the memory usage and define it by some PromQL, or you might want to use the CPU saturation of a node in your cluster, not related to a microservice, but if you want to evaluate this also in your quality gate, then feel free to do so, but just putting this as an SLI with a name and the value. As said, the value will be the PromQL, or if you're using other tools, it's just the API call for the other tools. If you're writing these SLIs, I've recently stumbled upon a tool called PromLens. It's a helper tool that help you build your queries. It's open sourced. I think there's also a commercial version, but make sure also to check this out to write your PromQL and also to validate the PromQL if it's actually correct. For writing SLOs, it's a little bit, I would say there are a couple of best practices. I would say define both a warning and a pass threshold for crucial SLIs. So in case you're not getting the full points, you still get half the points. And you can also define it as a key SLI. So in this case, it has to be evaluated, and you will receive a warning if it's not passing, or if it's like below the warning, if it's failing at all. Also include non-crucial SLIs in your SLO file. In this case, this data will also be fetched automatically by Captain, and you have it in the Captain dashboards or in the result that is given back to you by Captain. That's very valuable if you think of something where you don't know a good threshold yet because you have never thought about this SLI. But if you want to learn how is my application actually behaving, start by including more and more SLIs just as an information into the SLO file, and then you can make decisions upon them later, and then you can define the goals and the SLOs upon it later on. And also a last recommendation from my side: use a combination of relative and absolute values to avoid regression. That means if you want to define it has to stay, let's say the response time has to stay lower than 200 milliseconds for this test run, it's a good idea to also put another threshold in it, and it has to be within an increase or decrease of, let's say, 15% to the previous runs. So in case there is a very strong distinction or strong change to the other runs, you get kind of alerted. So you know, okay, maybe this the refactoring was a little bit too good, and I mean it was too good, and maybe now it's not doing the same amount of work, or it's not doing the same amount of necessary checks or whatever. So you can use it in both direction, and I think it's a good way to use this combination of relative and absolute values to avoid regression. So it's not getting slower and slower each time a little bit, so you can check the previous result, but also if it's getting too good, a little bit too good to actually believe it, you can also check this by using lower and upper bounds. So how is this SLI and SLO evaluation actually working? So I've talked about it a little bit, but I also want to give it an example. We have defined 4 different service level indicators: the response time in the 95th percentile, the overall failure rate, and then only for the login transactions, the response time and the number of database calls. Basically the same as we've seen before. And we define some SLOs for the service level indicators, so we're reusing this, and we define pass and warning criteria. As said, pass and warning, and sometimes make just a combination between absolute and relative thresholds. So with this, we also define it will be a pass in total, the overall score. If it's higher than 90%, we will assign it a pass, and if it's lower than 90% but still higher than 75%, we will assign it a warning, but still in Captain would be allowed to move on to the next stage. But as said, if you just interested in the results, then you can integrate it in a way that you want in your pipelines. So we are now starting our first build. We are basically sending this build to Captain. Captain starts the deployments, triggers the tests. Once the tests are finished, Captain triggers the evaluation. So it evaluates, reaches out to the data providers. So in this case, might be Prometheus, reaches out to Prometheus, fetches all the different data, and then evaluates. Everything looks good in this case. So we are not going through this item by item, but just build number 1 is totally fine. We get a result of 100%. Build number 2 comes along. We see slightly different values for our metrics, but still we get like 75%, which should be good. So we can go on and deploy build number 3. So build number 3 has it's one single, let's say one single metric, which is not very satisfying. So we get 0 points for this, which slows down or which decreases the overall goal, the overall score, and we're not reaching the goal. So we need another build, and it will be build number 4 where everything's fine again. So it's just like a little bit of an explanation how those different SLIs and SLOs work together, and how you also get the trend over time, since for each build you're evaluating, so you can also see a trend. Captain has its own dashboards where you can see it very nicely how builds and deployments are developing over time. And you might also see which are actually the metrics that are breaking the most, which are the metrics that are always fine. Should I maybe tweak them because they're always a little bit too low, a little bit too high? If you have the combination of relative and fixed thresholds, it's very easy to find out a good combination and to make a very strong quality gate in terms of writing a very strong SLO file. So how to integrate these quality gates now into your pipelines? As said in the beginning, there are basically two methods how to include it. The first one is to use the Captain CLI. So you can use the Captain CLI in the whole workflow or in your own pipelines. And it's event-based. So you're sending the event start evaluation, it's called, and you just add a little bit more information, which project, which stage, so Captain knows in its internal Git repository where to look for the SLI and SLO files. Maybe here is a little side note. Captain is organized in a way that you add the SLI and SLO file to a stage in the service. So if you want to evaluate for production, you can define your very own quality gate, and it might be very different than if you're evaluating in pre-production or in the testing scenario. Like in a performance testing scenario, you might want to evaluate for performance metrics, but in production, you might want to evaluate for errors. So it's might be very different, and you can easily add those files to the different parts to Captain. So in this case, we are looking for the hardening stage and for microservice with the name cards. And we're defining the start and the end time. And in this case, we are evaluating this. With Captain Get Event Evaluation, we are actually getting back the evaluation result. So in the first case, we are starting the evaluation. Captain will reach out to the data providers. Captain will fetch all these metrics that we've seen before in the slide. And this might take a minute or two, depending on how fast these external systems are by providing data. And then Captain can do this evaluation. And in the first command, Captain will give you back a Captain context, so to say. And with this Captain context, you can then fetch the evaluation done event. You can do the same also with the Captain API if you don't want to install the Captain CLI, and you send to the Captain API the endpoint to the API endpoint a post request to start the evaluation. You define the same values as you have on the left-hand side as part of the cloud event that you are sending to Captain, and afterwards you're sending another. You're doing another API request by getting the latest evaluation done event with this Captain context that you've received before. So in this case, you can do either way, whatever is like most satisfying or most suitable for you, so to say. There is actually a third way. If you're using Captain in its full configuration and full installation option, you can do the deployment with Captain. Captain is using Helm for the deployment, but you can also connect other tools like Argo CD, Argo rollouts. You can also include it to your Jenkins to trigger parts of your Jenkins pipelines. And with this, you can tell Captain to start this whole event workflow, how to start this whole deployment workflow by sending the event about a new artifact. So this new artifact basically comes out of your CI process. So you build your microservice, and afterwards you receive a container image with a new tag, with a new version. And this new version you're sending with the Captain CLI to the Captain control plane. So Captain goes ahead, updates its internal Git repository, fetches the image, and then starts to deploy this image. To pre-prod, it starts to trigger the tests. Which tests to trigger are defined in Captain, again, as a configuration, which test to trigger. Afterwards, when the tests are done, Captain knows when the tests were triggered and when the tests have been finished, so Captain can reach out to the quality gate and can do this evaluation for this exact time frame. And Captain also knows with all these SLIs that you have defined actually how to query the correct data. Captain will evaluate this quality gate and give you a thumbs up or a thumbs down. If it's a thumbs up, Captain will automatically promote it to the next stage or roll it back to the previous stage. And either way, or actually, if it's promoted to the next stage, it will do the same workflow again, deploy it, run some tests, trigger the evaluation again, and then again can roll it back to the previous version if it's breaking in production, for example. Or if it's not even promoted to production, Captain can already roll it back to the previous version here in pre-prod and inform your developers that something was not satisfying. So Captain is integrated in a couple of different tools. I've just put here one example, and this one example is of GitLab. One user of Captain has done this. As said, it's an open source project, so we see a lot of people working with this. And in this case, Christian Heckelmann, he's from Germany, and he was doing this in GitLab in their own organization, and he's using the Captain evaluation that is reaching from GitLab. It's reaching out to Captain, and Captain is then reaching out to the data providers and is doing the whole verification. So we already have our SLI and SLO files. So we can do a little bit more with this. We defined the quality criteria and we defined how to fetch the data. So why not also reuse this to set up alerts in Prometheus Alert Manager? So now we are a little bit switching from continuous delivery and progressive delivery with, let's say, canary releases. We're a little bit switching to also now already a little bit to operations. So we can base our alerting on the same input files because we have already defined the needed quality checks or the needed quality criteria for our microservices and applications. And it's not unrealistic that you deploy it to production, everything looks good, but you cannot really foresee all the user interactions. You cannot really foresee the traffic that is coming to your web services. So there might be an increase of this of the traffic. There might be some unforeseen user actions on your web presence. So with this, you might also want to have some alerts set up in Alert Manager, and you can reuse your SLO files. So how does it work? When we take a look here, it's the same file on the left-hand side, and Captain has it's also an integration to configure Prometheus, to configure Grafana, to configure all these other tools. So in the beginning, I was more talking about how to query the whole data, but it's also possible to configure these tools. So we take the same files and we use Captain to configure the monitoring solutions. So if you want to configure Grafana and Prometheus, we consider them as the same, in the same ecosystem. Most of the folks that are using Prometheus are also using Grafana, so they can connect both tools to the Captain control plane. Both tools, they will be interested in the same cloud events that will be received by the Captain control plane and distributed by the Captain control plane. So if there is a cloud event about the configuration of Prometheus distributed by the Captain control plane, the Grafana service and Prometheus service are listening to it. This is how they're implemented. So Captain control plane will distribute them, and the Grafana service and the Prometheus service, those two are services that are living next to the Captain control plane. They now do this, I call it here a tool-specific interpretation and execution. So basically they are taking a look at the cloud event, and they are generating from this cloud event, they are generating the needed either data structures or API calls. In the case of Grafana, they are actually generating the JSON for the dashboard configuration and doing an API call to Grafana with this JSON as a payload to setting up dashboards. In the case of Prometheus, it's the data is interpreted in a way to set up scrape jobs and to set up alerting rules in the Prometheus Alert Manager. So it's basically that parts of the SLIs and SLOs are inverted instead of saying it has to be smaller than 10. Every time it's higher, we want to have an alert for a specific time frame. So we can configure Grafana, we can configure Prometheus, we can configure even more tools. So whatever tool is interesting for this kind of cloud events can subscribe to it. In this case, it's Grafana and Prometheus. So now we have our, we call it a closed loop remediation with Captain. We have our Captain quality gates in place that should prevent any bad builds to reach production. But as said, there might be something that we could not test or that our test cases could not reflect the real traffic that is actually going on in our live systems. So we have set up everything with Captain. We have our quality gates and we have set up our alert manager in Prometheus. So if Prometheus now sends some alert to Captain, it will be received and it will be interpreted and sent to the Captain remediation service. So Captain itself also consists of a couple of services. The one is the quality gate, another one is the remediation part. So the remediation service will take a look if there are any remediation actions defined for this microservice that is facing some alerts and facing some problems. So a very easy description of a remediation file is shown here on the left-hand side. So basically, it's a YAML file that describes a sequence of remediation actions that should be triggered in case something goes wrong. So here we have, if there is we have remediations to solve response time issues. So it will be opened whenever there's a response time degradation problem. So the first one is basically for saying, sorry, we can go here. So if the problem type is the response time degradation, we have two actions. So these two actions will be triggered when the problem is open. So the first action is scaling the replica set by 1. The name is just the human readable name, but the action is really the one that will be interpreted by Captain and then will be given to action providers. So the scaling can be Kubernetes scaling, scaling can be in some other orchestrating tool. In our case, scaling is reaching out to it's rewriting the Helm charts and storing the new version of the Helm charts in the Git repository and applying this. So it's basically executing the remediation action, in this case, first the scaling, and afterwards, it's reaching out again to the Captain quality gate and starting the evaluation. So it's not, we are not using only the SLOs for configuring the alerts, but now we are again reusing them with our quality gates to check if the action that we've just triggered actually did the job correctly and the problem is solved. If it's not solved, if we still cannot generate a sufficient score with our quality gates, we will do the second action. So the second action in this case is to stop a campaign. We have also included, or we have an integration with a feature flagging framework called Unleash. It's an open source tool. So we have integrated this. It's listening for the toggle feature actions. And it's basically receiving the value data structure. So the status is to disable this campaign, and we have for campaign, we have the campaign ID. So this Unleash service knows which feature flag to disable. And you can easily reuse those files, and you can also easily exchange the files or exchange the action providers, so to say. So if you're not using Unleash, but maybe you're using Launch Darkly, or you're using Split.io, you're just using some other feature flagging framework, you can easily just change the action provider and you can keep the same remediation file. The same is true for the SLO files. So we can keep the same SLO files if we change from one data source to the other. The only thing we have to change is the SLI file. So everything is very loosely coupled, and it's very easily to reuse. So in this case, we stopped with doing the feature toggle. So for example, we are doing the feature toggling with Unleash. Once Unleash is finished, Captain will do another evaluation of the quality gate. If it's now satisfying, the remediation flow will stop. You might have more remediations that say actions on close, so you can send out some notifications that the problem is now automatically solved. Or if if the remediation workflow is finished but it's still open, you can also escalate it to Slack, to Teams, to a ticket, to whatever tool you're integrating here. The important part is really that you have different ways to, or you have very easy ways to connect the tools. This Captain is the control plane, and you just have to connect the tools, and they only have to understand cloud events, which is an open CNCF project standard, and Captain itself is also a CNCF sandbox project right now. So we are in a very good partnership and a very good neighborhood, I want to say, with like Prometheus, Istio, Cloud Events, Helm, and all these kind of cloud native projects. So with this, I want to summarize what I was actually talking about now in the last like 40 minutes. So first of all, manually evaluating and approving the builds is a very time-consuming process. I've taught, like we've seen this together, all the different metrics to evaluate them, to take a look what is actually important. It's very time-consuming. It might be a prerequisite for everything else you do, but I would suggest to use automation to really query the relevant metrics and compare them to well-defined quality goals. And these quality goals, they can be defined in different ways, but we have seen using SRE principles is a very, very mature way how to do this. I think in the last 2 years, we hear a lot from the site reliability engineering community, and I really love the concept of SLIs and SLOs, and this is why we also included this concept into Captain, this open source framework that I was also presenting here, and how it helps you really to automate your quality gates. And those SLIs and SLOs that you define in Captain are not only for the quality gates, but I've shown you also how you can use it for the configuration of alerts and how to check if your auto remediation and your self-healing is actually working. So with this, if you liked what I was talking about, check out captain.sh, that's the open source project. We also have a tutorial website where you can basically take a look how to really use it. It's a step-by-step instruction for different use cases, like doing quality gates or doing self-healing. If you want to contribute, we are happy to see you contributing on GitHub. If you like it, also star us on GitHub. We're always happy to receive stars. And there are other ways how to follow us and how to get all the news. So with this, thank you very much. And I'm happy also to answer questions. Again, if you want to connect, feel free to reach out on Twitter. Thank you so much.